to today's webinar, The Democratization of Computational Fluid Dynamics, How Modern CFD is Enabling Innovation at Startups for Hypersonics, Electric Mobility, and Other Advanced Technologies. With your presenters, Chris Ostoich, Project Engineer, and Adam Green, Business Development Manager for ATA Engineering. My name is Maria Ma, the Marketing Campaign Coordinator for Engineering.com, and I'll be your moderator today. Now, without further ado, I'll pass it over to our first presenter. Adam, over to you.
Thank you. Thanks everyone for joining us today. And we're here today to talk about modern CFD, and especially Star-CCM Plus from Siemens. And I thought I would start off with really what is modern CFD versus where it was, some time ago. And in the 80s and 90s, I used to work for the UK Ministry of Defence and working on CFD simulations of naval vessels. And back then, it was a different world. We had no 3D CAD. We would do geometries measured off paper. We'd manually create our meshes using 3D body fitted coordinate meshes, which seems almost laughable nowadays that we had to go to those acronyms. We would run on a Cray and we would view the results using our own visualization tools. And all of that process was very lengthy. And when you look at the mesh styles we could do then, a single block body fitted coordinate mesh looked like something like this. And imagine trying to wrap a single mesh block like that around a ship hull or even a submarine. It was no fun. I mean, it was fun at the time. It was considered state of the art, but it was tough by today's standards. And so when you look at that process, it could take up to a month to really run one mesh and run one hull form at one speed to get an answer for, say, resistance or something like that. And when you contrast that with modern CFD, it's extremely different, as all of us are aware, and many of us are using it already. So this is the kind of thing we can achieve today. And Star-CCM Plus has got us to this point, and continues to be developed at a very rapid rate. So today we're going to talk about what are the pieces in Star-CCM Plus that really make it accelerate the process of doing any CFD more rapidly, and really open it up to almost anybody from small startups to large companies as well. And so the key subjects that we're going to talk about today, and Chris is going to dive into these in a few moments in more detail, is really the whole process of doing CFD. And those of you who are familiar with it know a lot of this, but really going from CAD to mesh is one of the key things. Rapid CAD import of almost any format, cleaning up the CAD ready to mesh, and then an automated unstructured mesh generation, followed by running that in parallel so that you can put a really big mesh really anywhere, either in the cloud or on your own HPC to mesh it very quickly. Then at runtime, do adaptive mesh refinement to really home in on some of the advanced physics that might be going in on your model. And then when you want to do all that again for a slightly different parameter, make it repeatable. So it's very easy to rerun the workflow once you've done it once. And when you sum those things up compared to doing a ship hull in a month, nowadays we can do this sort of simulation, doing advanced moving meshes with automatic mesh refinement following the free surface. I think you'll agree this kind of simulation is quite amazing nowadays, and has only really been available in the last 6 months to do all of these pieces with overset meshing, with moving geometry, tracking the free surface of the oil in this case. It's quite an extreme but exciting example of what we can do nowadays. And so then we also need to look at, can the CFD tool we're using predict the physics we need to do? And Star really excels in all of these. Multi-phase, we'll see some of that later, combustion, heat generation, conjugate heat transfer, as well as really looking at motions of bodies, of either gears, as in the previous example, or in this example of a moving ship, a planing hull through waves. So really any physics that can be considered, Star-CCM Plus has a really good shot at actually being able to simulate them. Now all of these things take a considerable amount of compute power, and so we're going to talk later in our hour about how to really deploy these kind of simulations in the cloud, really to make anyone who wants to do them, even individual consultants, can do very big scale computing in the cloud, and we'll talk about that later. Optimization and workflow automation is very important. We'll be talking about that too. And then really, if you want to do all of these things, one of my licensing choices to try that. We'll talk about that too. And so this is a recent example that was done of automating workflows for an HL-20 body from NASA and looking at shock waves around it. I mean, in this case, the angle of attack is being varied in each case, and the system automatically tracks the shock by moving the mesh and refining the mesh around the shock in each case. So a run like that can be set up automatically, and then a whole sweep of angle of attacks can be done very easily. So to sum all of that up, in the 80s and 90s, we were doing one ship per month. Now, using all of those technologies, which we'll dive into further, hundreds of designs can be looked at in a matter of hours, especially using big cloud deployments. So really any company, large or small, can use this technology and really aid their business for either consulting or internal projects. And with that, I'm going to pass the ball to Chris.
All right, great. So as Adam was alluding to, Star-CCM Plus helps us achieve new levels of productivity and just makes our process much more efficient. And I'm going to go into some of the details of how that's done. I'm going to cover an efficient CAD-to-mesh process, parallelized high-quality meshing, and adaptive mesh refinement. And so I'll start with this CAD-to-mesh process. So over the years, our CAD tools have allowed us to design very intricate solid models. And while Star-CCM Plus has a CAD tool built in it, a native CAD tool, it's not quite as good as one of these dedicated CAD tools, but that's why Star has enabled kind of a handshake with more powerful CAD tools such as NX-CAD, so that we can use some of the powerful mesh operation pipelines within Star-CCM Plus, coupled with that CAD tool to make changes very easily in an automated fashion. This allows us to run parameter studies really hands-free. So that means setting up a study over the weekend, going home, and seeing the results on Monday. Taking a step further, it allows us to do automated design exploration to really hone in on a optimized solution to your product design. So one example of how we at ATA Engineering could have used this CAD-to-mesh process was in the development of the ATA engine air brake. Some years ago, some of my colleagues developed this engine air brake mechanism, which uses a deployable swirl vane mechanism at the end of a nozzle, which essentially converts engine exhaust from thrust production to drag production. This enables slower, steeper, and quieter flight on landing approach, which is very important for airports in noise-sensitive areas. So as we didn't use the CAD-to-mesh process, this analysis-driven design was manual, requiring 150 CAD models and CFD simulations to arrive at the final design. This equated to several hundred engineering hours and was an expensive process. However, now I just took that model again and used the CAD-to-mesh process to make all of the design iterations much more easy. I flagged a parameter in NX to make that parameter available to modify within Star. In this example, it was the swirl vane angle. And then from there, I could just change the angle within Star-CCM Plus interface. In the background, NX would modify that CAD geometry and send it back to Star-CCM Plus. Star-CCM Plus would automatically remesh and run that updated geometry. So you can see it's a much more streamlined process requiring very little effort from me. So this is one example of how our CAD tools are producing, more complicated, detailed designs. Here's another one. This is a vehicle underhood flow. And so using the CAD-to-mesh process, this works very well with Star-CCM+, and then this also shows how Star-CCM+'s parallel mesher can easily tackle this problem by meshing a very large mesh over a large number of processors and ensuring that you get a good quality mesh so that you get a good quality solution out the back end. So those were examples of how the process could be made more efficient, but I now want to talk about adaptive mesh refinement, which allows a given simulation to be more efficient. This gives you computational efficiency by allowing a coarse baseline grid and only refining the grid where solution gradients need to be resolved. I'm talking about places like shock fronts in supersonic or hypersonic flows, the free surface on a free surface flow, much like the oil flow simulation that Adam showed, and also to resolve disparate length scales between overset meshes and their background meshes, as shown in this gear meshing example on the right. And again here, I show how adaptive mesh refinement can, make a single design iteration more efficient, but can also make the entire design process more efficient. In this case, we're running a parameter sweep where we can just start with a background grid and rely on adaptive mesh refinement to resolve the shock structure for each angle of attack that we're running this hypersonic body through to generate a lift coefficient or drag coefficient curve. So Star-CCM+ not only allows us to be more efficient, it enables us to more closely approach reality with our simulations by providing powerful high fidelity models. I'm going to talk about today the multiphysics modeling capabilities, the chemically reacting flow models, conjugate heat transfer, and I'll finish off with an example of 6-degree freedom motions. So Star-CCM+ provides a large number of multi-phase flow modeling techniques, which can be applied to an array of applications, as you can see here. I'm just going to cover 2 examples, but should hopefully give you an idea. In this case, I'm showing the fluid film multi-phase model, as the name suggests. It's designed to resolve the flow details between a very thin fluid film and some surface. In this case, this is rainwater beating on the surface of a windshield, and we're looking at the effectiveness of these windshield wipers. A lot of times, though, you might want to take a hybrid approach. So in this case, we're actually using 2 different multi-phase models. This is an example of a mechanical kind of painting process of a surface. And so we're using a Lagrangian multi-phase flow model to model the particles or the fluid particles of paint being released from this nozzle here. And then once they hit that surface and spread, we're using that fluid film model that I spoke about in the previous slide to understand how that spreads over the surface of this well. So now I'm going to speak a little bit about the reacting flow models, and just like in the multi-phase flow models, there's a large suite of reacting flow models to choose from. I'll again just show a few examples. An example from the lower end of the spectrum in terms of complexity is the chemical equilibrium model, which just assumes chemical equilibrium. So we're not really modeling the evolution of individual reactions. We're just assuming at any one point things are in chemical equilibrium. But this assumption is good in some applications, for instance, to model fires. So on the right, we kind of demonstrate how this less complex approach does a good job. In this case, where we're modeling this fire and we're comparing the temperature profile in this doorway with experiment, the Star-CCM result does very well. But of course, there are more complicated models. In this case, we're doing surface chemistry on a free surface or within a fluid volume of a sulfur removal copper converter. So here we've got molten copper on the right, and we're piping in some oxidizer through the bottom. And this is actually a hybrid between a multi-phase and a reacting flow simulation. So we've got this oxidizer being piped in. It's being resolved by a volume of fluids multi-phase model. And then as it becomes dispersed near the surface, it's using an Eulerian multi-phase model. And within these interactions, we're also modeling the chemical reactions that are taking place. Another case where that involves chemical reactions is combustion, and in this case, a gas turbine engine. So in a lot of cases where we're looking at combustion, we're concerned with heat generation and how is the structure surrounding that combustion going to deal with that. Star-CCM Plus is well suited for this type of simulation, for instance, gas turbine engine simulation. It allows you to take a complicated geometry, generate a high quality conformal polyhedral mesh, accurately model the combustion with an efficient flame model, and then predict the temperature evolution within the engine structure under the convective thermal loads that were computed with the CFD model and radiative thermal loads between the surface and the fluid medium. And then, so here's an example of a fluid structure interaction, and in this case, it's really showcasing a lot of what we've discussed, not just fluid structure interaction through this 6 degree of freedom motion solver, but also automatic mesh refinement to resolve the fluid surface. We've got multi-phase. We're simulating the dynamics of the water and then also the air. And we're looking at how that interacts with the boat so that we can get very high quality predictions of this very complicated scenario. And then to kind of the cherry on top is the advanced rendering that is available within Star, so you can actually generate a video like the one I'm showing here that looks very realistic. So that is the end of my slides, so I'll pass it back to Adam.
And so we're going to talk about basically cloud computing initially and how to use that, how optimization and workflow automation really goes along with that, and then look at the licensing for choices to deploy in the cloud. And so let's talk a little bit about really parallel scaling of Star before we go into the cloud side of things. This is an example from Siemens of a 20 million cell CFD model, Star model, around an aircraft. And it was run on 1,792 cores. And basically was very scalable at that level and was a realistic thing to do. Obviously, 20 million cells is not going to run on a local desktop machine. So if you wanted to do this scale of modeling, you need to either have a big internal machine or go to the cloud. And so when you look at that, if you take your models, can I scale, infinitely? If I can go to AWS and I can get 10,000 cores, why not put all my models out there to do that? And obviously that would be great, but it doesn't quite work that way, in that not all tools are totally scalable, and the size of the problem kind of governs that a little bit. But in this case, you can see that up to 896 cores, this case scaled almost linearly to the speed up and the number of cores. It tailed off a little bit as you got to more cores, mainly because the compute time starts to become significant, or sorry, the data transmission time starts to become significant compared to the compute time. So if you carried on adding cores to run this, you would lose some more efficiency as you got more. But really, 1,000 cores, say, would be a good starting point to run this on. And so, okay, where can I get 1,000 cores from? Is something that, you know, obviously would cross everybody's mind for any project. And going to the cloud is very easy. Basically, with Star-CCM Plus, it'll run on all the major cloud services and cloud vendors, through AWS if you're skilled and familiar with that, and right the way through to Rescale for a simplified platform, and really all the others. It's really cloud agnostic as to which ones it'll run on. But certainly, I would recommend that you all think about this as a way to accelerate your CFD modeling. And so when you look at that, if you consider an automated process, this is an automated process of Star-CCM Plus doing simulation of a ship hull, looking at also the hydrostatic calculation for the sink and trim of the hull before the resistance calculation is done. So this includes NX to create parametric geometry, the two simulations, and then kind of rinse and repeat is really the situation here. And then at the bottom you can see that every one of those points in that table is a complete simulation of the CFD model. So just keep in your mind, in the 80s it took a month to go around this loop once, pretty much. Now we can do hundreds of models, you know, in parallel. And so you need the CAD tool to be able to do parametric CAD. You need the connection to the simulation tool to be able to really bring that CAD in easily. You need to be able to create the mesh automatically and then run it and then do it again. And that's exactly what Star can do very easily, in this case coupled to HEADS. And so if you wanted to do this exact process, you know, how could you actually run that? What would the compute topology look like to run that? And this is what it looks like. So HEADS is the optimization tool from Siemens that is kind of controlling everything, and that can run really on any machine, a laptop in this case, just to highlight that it can be a low-powered machine. And so can NX CAD, really creating parametric geometry. You know, most laptops are pretty good to be able to do all of those things. Then the hydrostatic calculation here was done on a slightly bigger workstation, and could run 8 jobs at once. And then the final CFD model was farmed out to the Rescale cloud, where they had 24 cores per node and per job, and they could run 8 concurrent jobs at any one time. So you can see that basically doing this loop, first of all, it's very quick, it's very efficient, but it's also available to anybody. Even if you're a single person consultant, you could deploy exactly this situation very easily. And so if you wanted to do that with Star, how would I license that to make that happen is an obvious question. And one of those is basically using the Star-CCM Plus power session or power on demand license. And the key thing here for both of those licenses is that they are both unlimited cores. A power session is either an annual or a perpetual license, and a power on demand is basically renting a power session by the hour. And the nice thing about it is that it doesn't count any cores at all. So if you've got a job that will scale to 1,000 cores, then basically you should do that, because it's a much more efficient way to do it from the cost perspective, especially the license cost. It's licensed by the hour, hence the quicker you can do it, the more license cost you can save. Obviously you're going to pay more on the AWS costs for, or really any cloud service core cost, but it's quite clear that if you can scale a problem out, then the hardware costs become insignificant compared to the license cost. So this is really a way to to get the best you can from a power session or power on demand license. And the other nice thing about power on demand is that it doesn't need a FlexLM or a complex licensing structure. It's basically a long registration number that you type in at the beginning of a run that's remembered for future runs, but it does everything else for you. That's all you need to do. So getting it up and running is very fast, much faster than a power session, which needs a FlexLM license to run. And also note that pretty much all of the cloud services need you to bring your own license. They'll help you configure it, and we can help with that too, but you still need to have a license kind of in your hand to start using the cloud system. So with that, how far have we come? We've covered the levels of productivity. We've covered the advanced physics from Chris, thank you, and we've looked at how we can expand as needed. And so really, we can cover really 100 design iterations really in 10 hours running on multiple machines and multiple cores. It's totally different paradigm to the 80s where it took us a month to do one. So now really any company can tackle large CFD projects with available cloud resources on demand as needed. So spending dollars on power when you need it and saving dollars when you don't is always an attractive part of the cloud and the POD licensing model. So with that, I thank you very much, and we will field any questions that we have out there. Thank you, Maria. Back to you.
Awesome. Thanks, Adam. So our first question comes from Risha. What are the different tools that were used in design exploration case study? And how easy is it to integrate all these tools together?
Chris, perhaps I can take that one. So in that case study, they were pretty much all Siemens tools, which makes life a little easier for us because they all talk to each other very cleanly. NX was the CAD tool that was used, and it talks with Star-CCM Plus directly, and it's all controlled by an optimization tool called HEADS, which is also Siemens. So those all play very nicely together, and it's very straightforward to make an automation loop. But HEADS very nicely also covers pretty much almost all engineering tools available, not every single one, but all of the mainstream tools. So if you said, well, my CAD wasn't NX, my CAD was, CATIA, HEADS can control that too, and also there is an interface from CATIA into Star. And so really, the nice thing about using HEADS is that it can control almost any of the main CAE tools that are out there to construct design exploration loops like we showed you.
Awesome, thank you. Next question comes from Ali. What is the role of HPC in modern CFD?
Ali, I think when you say HPC, I think I'd like to clarify that a little bit. And really, HPC is twofold. One is on-premises HPC, which would be, a large Linux cluster that you would own and you would run simulations on it, and the other would be the cloud. The role of HPC in modern CFD, I think is clear that it's almost essential. Even if you go down to a basic desktop workstation, which may have 16 cores, it still starts you on the road to multiple core computing. And so the fact that the cloud makes it available to anyone who wants to can basically really deploy big scale projects on multiple thousands of cores. And then when you want to do optimization, you really can do things in parallel. So if you wanted to run one ship model in that case at once on the cloud, you can then run 10 of them at once if you need to, and really accelerate the pipeline using HPC. So I think that's probably the future of where HPC is really going to change things, that not only can we do a single point faster, but we can do multiple points much, much faster.
Thank you. Next question comes from Omar. With costs being dependent on simulation time, what methods are used to predict that time?
Chris, can you take that one?
Yeah. So Omar, you can, a lot of times the approach is you have an idea of how to simulate or how to run, say one iteration on how long it takes to run one iteration per mesh on a given number of cores. And from the scaling information that Adam showed you, you can then understand, okay, I want to run X number of iterations, so I'll multiply that time by X, but I'm going to divide it by N, the number of processors, and that gives you kind of an idea of how you can estimate the runtime for a given simulation.
Awesome, thank you. Next question comes from Shintanu. Many of us are beginners here when it comes to CFD. Does Star-CCM Plus come with a learning module?
Yes, it does come with training, if that's what you mean by learning module, and training is available to everyone who needs to do it. And also there is a student edition that you mentioned. So really for people doing academic work, Star-CCM Plus is available at very, very low cost. And so certainly that is a big thing for Siemens to support academics and students. And then training, really the commercial training classes are also available for students, and normally when there's space they'll be allowed to attend. So the answer is yes. You can't just start using Star-CCM Plus and expect to be proficient in a few days. It certainly takes some training and some time, and so basically the training is available, and certainly reach out to us and we can give you more details on that.
Awesome, thank you. Another question from Risha. If I am doing multi-scale modeling for my design exploration, where I have to use ANSYS, Abacus, MATLAB, NX, let's say, can HEATS orchestrate all these tools together in an automated workflow, or any other tools like HEATS which can do that?
Yes, I'll take that. So yes, HEATS can basically orchestrate all of those tools and build a full workflow controlling each. And so HEATS comes with a set of APIs that lets it talk to all of the tools you've listed there. So it can reach out with basically the parameters you've defined. It knows which are parametric variables in each of the analysis tools, and it can manipulate them, run a simulation, and then pass those results on to the next phase. So yes, I think all of the ones you've listed, HEATS can talk to very cleanly, and it's a very simple process to create an optimization loop.
Thank you. Next question comes from John. What CAD formats can I import into Star-CCM Plus?
Chris, do you want to take that?
Yeah, you can import a large number of different CAD formats. So you can, import neutral formats such as IGES-STEP, Parasolid is one that I use a lot, ASYS. But you can also import some native formats from different packages like NX part files, Inventor, assemblies, SolidWorks files, and CATIA.
Great, thank you. Next question comes from Huli. Is all of this cool post-processing using Star-CCM Plus?
Chris, you want to take that?
Yes, everything that you've seen here was post-processed using Star-CCM Plus. I especially like the, champagne glass being filled. That was a demonstration using multi-phase modeling. And then Star-CCM Plus has a very powerful rendering engine, so you can specify the glass as, transparent with some refractivity. And then more recently, it's introduced something called screenplay, where you can kind of be the director and move the camera however you'd like to create some very powerful visualizations.
Great, thank you. Next question comes from Sholi. What are the real upsides of your product compared to using something like SimScale or the add-ons Siemens provides?
I can take that one, Chris. So Zoli, Star-CCM Plus is really the premier CFD tool from Siemens, and so it contains the best technologies that Siemens has for meshing, for physics, for productivity. And as you know, Siemens has various other tools that sometimes plug into the CAD tools and really work very well in that environment. But if you really want to do advanced physics with advanced things, then Star-CCM Plus is the main product to do that. Certainly, if you just wanted to do straight airflow through a CAD geometry or heat transfer, then things like Flow EFD connected to NXCAD will work very well. But they run out of steam when you want to apply more advanced physics. So I think that's the answer for that one.
Thank you. Next question comes from Max. Can a design manager replace the role of HEADS?
It can to some extent. Let me take that, Chris. So HEADS is a product that does full design exploration to enable, not complex, but advanced design space exploration for really any design space. And so that includes search engines for navigating the design space and various other things. Design Manager is built into Star-CCM Plus and comes in two flavors. The Design Manager that comes included with Star-CCM Plus is basically a way to automate parameter sweeps, which can be a matrix of parameters, but it's still really what will run everything. But the other tool within Star-CCM Plus is basically a mini version of HEADS that lets you drive full automated design studies. So Design Manager itself will let you do parametric sweeps, but it doesn't include the automatic search engine that HEADS does include. But there is an add-on to Star that is lower cost than full HEADS that will let you do that.
Thank you. Next question comes from Shatanu. As you mentioned earlier about reaching out, can you clarify how they can contact you?
Yes, well, we will reach out to everyone who attended after this, but you can also go to ATA's website, which is ata-e.com, and reach out to us there. But we will reach out to everyone who's attended.
Awesome, thank you. Next question comes from Risha. During automation of simulation workflow, how do we take care of knowledge and information to be used, which has to come from subject matter experts? Is it manual intervention or can that also be automated?
Chris, do you want to take that one?
Automation.
Chris, you there?
Yeah. Sorry, I'm. So, in terms of the various models that you're using, there are recommended defaults that are set that kind of well, they're the most generally applicable parameters or whatever. But the Star-CCM Plus manual also goes through how those parameters might be changed to apply to different situations. In addition, Siemens provides an online forum that's very actively added to kind of answer questions regarding various model parameters that might need tuning for a given problem.
Great, thank you.
In addition,
sorry.
Go ahead. Oh, I was just going to say, in addition, the support model for Star-CCM Plus is very unique in that a Star-CCM Plus customer is assigned what's called a dedicated support engineer that they can reach out to at any time, and the cost of their support is just rolled into the Star-CCM Plus product price. And so I happen to be one of those DSCs, and so different customers can reach out to me at any time with technical questions that they might have. And if I don't have the answer because it's not in my area of expertise, we've got a team of DSCs that have a variety of experiences that they can contribute.
Awesome, thank you. Next question comes from Mohsin. I want to know how to generate a good mesh because there are several factors involved in this process like base size, prism layer, maximum cell size, surface growth, etc. Could you please share your opinion on which factor is most important in generating a good mesh?
Chris, do you want to take that? We can also reach out afterwards in more detail, Mohsin, but Chris, can you give us the quick answer?
Yeah, well, it really depends on the level of fidelity that you want to achieve in your simulation and how much time you have. Obviously, a very refined mesh will give you your most accurate answer, and to determine what that mesh level would be, you'd have to go through a mesh convergence study. That being said, the mesher in Star-CCM Plus, especially 2020.1, is very easy to use and really ensures that you get a good quality mesh while tuning very few parameters. What I'm trying to say is the mesher does a lot of the work for you in ensuring that you get a quality mesh and requires very little tuning.
Great, thank you. Next question comes from Sholi. Do you use the cloud providers you showed us, or do you have your own dedicated cloud computing in-house?
So Chris, I'll take that. So we have used a number of those resources. We've used Rescale, and we've also used Nimbix, and we've found the interfaces, very straightforward to use. Moving data out to them to run is very straightforward. We also do have considerable resources in-house. Normally, if it's in-house, it wouldn't be called a cloud, but nonetheless, I guess it's just terminology. But we have 256 cores in-house for doing our own computing when we need to. So really, only when we need to go bigger than that do we reach out to these other vendors. But really, we feel it's important for us to be familiar with these technologies to help with our clients who want to deploy on the cloud. So just like you've asked, if you need help running on any of those things, we can certainly help you out with Nimbix, with Penguin, and with Rescale very easily.
Thank you. Next question comes from Ayor. Is it possible to solve stationary problems using CCM+? By that, I mean when external tools are periodically on time.
Chris, do you want to take that?
Yes, although I have not done it personally, I believe that it is possible to solve problems. I mean, obviously you can do it in a time-accurate manner, but I believe that it's possible to solve, steady-state problems with periodic loads.
All right, thank you. Next question comes from Michael. CFD for automotive applications measuring drag, downforce, etc., comparing RANS, LES, DES, which physics model is better and which turbulence model will be better in your opinion?
So, Michael, I think that's a very long answer to that question. If it's all right with you, we'll come back to you and discuss it directly.
All right, thank you. Next question comes from Wayne. For dynamic meshing, is writing a UDF necessary in Star as compared to Fluent?
Chris, can you go with that one?
No, that's so. In certain situations, so the dynamic meshing is very easy to use, but you do have to tell it what to remesh, and that's problem dependent. If you want to, resolve a pressure gradient to resolve shocks or something, then you would build just a simple function saying, okay, I want to resolve based on the gradient of the Mach number or something. But there are other situations, such as in free surface flows, where it uses the free surface model itself to tell the mesher, the AMR, where to throw more cells.
All right, thank you.
Wayne, I'd like to add to that too, and that Star-CCM Plus doesn't use UDFs or need any recompiling of the code like you might do with Fluent. All of the controls that Chris just mentioned are done in the GUI in the interface. So if you want to refine the mesh based on, velocity profile, or really any variable. Those are all set in the GUI, and it's very straightforward to do. Certainly, you don't need to go to the lengths of writing a UDF to do it.
Perfect,
Thanks,
thank you.
Maria.
Next question comes from Roz. How much of using adaptive and optimized mesh of Star-CCM Plus will help, especially in mesh independency studies of cases like aeroacoustics and hypersonics? And also, how can I study more mesh systems for Star-CCM Plus?
So Chris, maybe I can take that too, because I think there's a general answer, and that is that, whenever anyone is doing CFD, there is always a limit of the amount of mesh that you can throw at a problem based on the compute power you have available, even if you do have cloud resources. So in the name of efficiency, you're always trying to use the minimum amount of mesh you can use to resolve a problem. And with adaptive meshing, if you want to track hypersonics or various sonic waves, then the meshing can resolve just around that and leave, expand the mesh outside of that zone of interest. So it really helps you home in on having the most efficient mesh for the problem. So I think really it helps because it can help you maintain the most efficient mesh that you can for really any given problem. And you meant your question says, how can I study study Star-CCM Plus? And we'll certainly reach out to you afterwards and send you information on training and so forth.
Perfect, thank you. Next question comes from John. Is it true that Python programming is used to automate in post-processing processes?
I would say no. So Star-CCM Plus is Java based, and so pretty much all of the post-processing, if you wanted to, could be Java based, but really very few people ever have to write code. None of the examples you've seen today were done writing code. They were all done using the GUI. There is a special video creation tool within Star-CCM Plus called Screenplay, which again is totally GUI based. And so the idea of writing Python, it never happens with Star-CCM Plus. Occasionally, very, very occasionally, people might want to write some Java to automate things, but that's about it.
Thank you. Next question comes from Wayne. Can you explain in brief the boundary conditions for the ship hull simulation?
Wayne, that would be quite long. I'll be happy to show you a deeper presentation of the ship hull simulation after the fact, after today.
Great, thank you. Next question comes from Arendam. Does advanced technology hamper our global or near future?
I'm not quite sure what that means.
Okay. Arendam, if you can please clarify, then we will come back to you. Next question comes from Adrian. Is Star-CCM Plus made up of component programs for pre, post, and solve?
No, Star-CCM Plus is completely one integrated program. It's basically one interface, one GUI, and everything that you've seen today happens in that environment. So reading in CAD, cleaning up CAD, meshing it's all in the same program. You then run it in the same program, and you post-process in the same program. There's certainly not a mixture of different tools needed to do that.
Perfect, thank you. Next question comes from Jim. Can you describe a cloud workflow for Star-CCM Plus?
Yes. So sometimes, when you run in the cloud, there's often this challenge of getting data out onto the cloud system. And so often a workflow for Star-CCM Plus might include having a local license of Star-CCM Plus on a desktop workstation where you are. You might run your CAD there, you might import your geometry, you might mesh it, you might get the model ready to run. And then you may send the geometry up to the cloud system, not the geometry, the whole data file up to the cloud system for it to run, on thousands of cores. Sometimes some of the more, graphical intensive parts of the process are better done locally, and then some of the batch computing done in the cloud.
Great, thank you. Next question comes from Jitanu. What level of CAD geometry cleaning can be achieved in Star-CCM+?
Chris, do you want to take that one?
Yeah, so Star-CCM Plus has, if there are, just a few things that might be messy about your CAD, it's got a native CAD modeler within Star-CCM Plus, so after you import your geometry, you can open it in that CAD modeler and tackle those, small issues. However, if you're just starting with very dirty CAD, that would obviously take you a very long time to tackle those one by one. So Star-CCM Plus has a very powerful tool called the surface wrapper, which I like to think of it as, okay, you take your CAD object, maybe it's an automobile or something, and then you blow up a plastic bag around it and then shrink wrap it. And that's what the surface wrapper is doing. So it's creating a watertight geometry for you to then introduce into your fluid domain. So that's one way to clean up dirty CAD. It's also a way to de-feature very detailed geometries that maybe you don't need such geometrical detail in your fluid simulation, so you can specify a minimum size for a feature, and the surface wrapper will filter out anything below that.
Thank you. Next question comes from Frank. Is AMR easy to set up?
Chris, can you take that one? I think we may have answered that one already, but can you take just quickly?
Right. Yeah. So I'll just it is very easy to set up, and you can the one task is just determining what the function looks like that you want to refine the mesh based on. And as Adam was talking about, it is very easy to define that function in Star-CCM Plus. You don't have to write a UDF or compile anything. It's really just entering an expression in a field, and furthermore, that expression is very easy to debug within Star-CCM Plus if you forget a parenthesis or something.
Awesome, thank you. Well, that's all we have for now, guys. Thank you, Adam and Chris, for providing us with great content and value today, and thank you, attendees, for joining us. We hope you'll return for future webinars. Bye for now.